Hello, Mary here. We are doing lesson number 4 in our Eat More Plants program today. So, with this program, we've been answering questions. We answered what is climate change? We answered what are greenhouse gases? We've answered what's the rush? Why is this important today? The question we're answering today is a question that, after answering those other questions, has been weighing on my mind, and maybe you've had the same experience, and that is, what can I do today that has the biggest impact? Well, the answer to that question is not all actions are equal, and not all foods are equal, and it's complicated. But thankfully, scientists from all over the world have been working on the answer to this question. In fact, they came together and wrote a wonderful, very informative book, and it is called, that I'm using for this lesson, it's called Drawdown, the most comprehensive plan ever proposed to reverse global warming. There you go. And what it is it's the top 80 things we can do to reverse global warming. And all the technologies and all the practices are available now. And the science and the economics are doable now. It's not pie in the sky. These are things we can do in the future. These are things that we're doing now and are doable now. So let's take a look at an example how this book works. Here's solution number 4, the fourth most impactful solution. And coincidentally, it is a plant-rich diet. And you can see here, come in, it has a ranking, number 4, and then it has gigatons of CO2 that will be reduced by 2050. So this is over 30 years. And so for each one of the solutions, they have this data. So it's really helpful in getting your arms around what we can do. All right, so that's the book. So there is a lot of information, and like usual, to get my head around it, I made a chart. So I chart looking at the top 5 things. So let's take a look. Here is the chart I made based on Project Drawdown's solutions, top 5 solutions for climate change. Okay, so across the top, I have the solution, the ranking, plausible scenario, gigatons reduced of CO2 by 2050, then a summary about that solution, and can I do this today? And by the way, in the book and in this chart, when I am saying CO2, I mean all greenhouse gases, and they said that in the book as well. And CO2 reduced includes avoided and sequestered. And sequestered means taken out of the environment. So, solution number 1, phase out hydrofluorocarbons. That will reduce 89.74 gigatons. And the summary of that is the chemicals, HFCs, used in our refrigerators and our air conditioning units trap thousands of times more heat than CO2. So, preventing leaks, properly disposing of, or recycling HFCs is essential. Can I do this today? No, not really. All right, solution number 2 is wind turbines, and that will reduce 84.6 gigatons by 2050. Interesting, wind energy will soon be the cheapest source of installed electric capacity. Wind farms can be built quickly, and the land they sit on can be used simultaneously for farming. An interesting thing that's happening right now in Liverpool, England, there's 446,000 people in that city. Soon the entire city will be powered by 32 wind turbines. They're double the size of the Statue of Liberty. An interesting thing about that project is is being done by a company that is new to the energy business. They're actually a toy company. You may have heard of them. Lego is the name of that company. Anyways, is this something I can do today? Not really. Okay, number 3, reduced food waste. That would save 70.53 gigatons.
by 2050. 1/3 of all food raised or grown never gets used, causing about 8% of global emissions. That's crazy, right? 1/3. Globally, distribution, storage, rejection based on looks, and inconsistent sell-by dates are contributors. Globally, solutions depend on changes in the food industry, policy changes, and active anti-hunger and environmental groups. But specifically in the US, 43% of wasted food comes from households. Food waste at home can be reduced by making small changes in how you plan, store, and eat food. This is easy and it saves money. And speaking of saving money, the World Wildlife Fund has a food waste reduction plan for schools. And one example from their plan is to change recess to before eating, because this reduces a huge amount of food waste in schools. Sounds like an easy fix to me. Anyways, can you do this today? Yeah, you can work on the food waste in your home. All right, number 4, plant-rich diet. That will save 66.11 gigatons by 2050. And here's the summary. If cows were a nation, they would be the 3rd largest emitter of greenhouse gases in the world. Meat and dairy cause way more greenhouse gases than plants. So the simple solution is to eat less meat, especially beef, and more plants. Can I do this today? Yep, I can. 3 times a day. All right. Number 5 is tropical forest, and addressing this would reduce CO2 61.23 gigatons by 2050. All right, so all forests are critical to storing carbon, but none more critical than tropical forest. Tropical forest loss is responsible for 16 to 19% of greenhouse gases caused by humans. Reforesting does the opposite, and it can be done. Changing land use and reducing meat dairy consumption allows us to feed a growing population without expanding agricultural acreage. Okay, so can I do this today? A little bit, by doing the two items above. So to summarize, the most impactful thing I can do today is reduce my food waste and eat a plant-rich diet. But since there is food waste all along the supply chain, eating less meat and more plants is very probably the most effective way an individual can fight climate change. So, plant-rich diet. Let's talk about that a bit more.
So after reviewing that chart, the bad news is there are few solutions of great magnitude that lie in the hands of individuals. However, the good news is, one of them, number 4, eat a plant-rich diet, is something not only can all of us do every day, but we can do 3 times a day or 4 times a day or however many times a day we eat. So if we're going back to wanting to have the most impact, we need to compare the foods that are available and what their impact is. So what I've done is a bar chart comparing different foods. And this is where the fun part starts, because the bar chart is the art lesson. So before we dive into the bar chart and I show you that, I want to review the materials you'll need. So I've made this lesson is 2 different kinds of bar charts. A 2D bar chart, which is just drawing. And for that, you're going to need a piece of graph paper. You're going to need colored pencils. A ruler would be helpful, but is totally not necessary. And you're going to need data. And that's what the chart that I'm going to show you will have. Now, also an option is to make 3D bar charts. And what you need for that, again, is data. And you'll need colored pencils. You'll need to make some labels and titles, so some white goose paper would be good that you can cut up. As a reminder, goose paper is good on one side. So basically it's maybe you've printed something on one side of the paper and the other side is blank, and you have your goose paper bin with all your paper that you can reuse, because we want to reuse if we can. Anyways, okay, so goose paper, colored pencils, scissors, tape, and imagination is really important for the 3D bar charts. All right, so let's take a look at the 2D bar chart and how we might do that.
Here is my food carbon emissions bar chart.
showing the pounds of CO2 emissions associated with a serving of food. So before we dive into how to make this bar chart, let's just review the data. It's pretty interesting when you compare plants, 1.6 pounds of carbon emissions, and that's for rice. Legumes would be 0.11, carrots even less, 0.07, potatoes 0.03. And you compare that to beef, which is 6 pounds, 6.61 pounds of carbon emissions for a serving. So also, not just comparing plants to beef, but other things like, look at cheese, which is 2.45 pounds, compared to poultry, which is almost half of that, which is 1.26 pounds. So this chart has been really helpful for me as I try to eat more plants, because I'm not always able to have something that's just all plant-based. Sometimes, let's say I'm in a restaurant, I have to choose between a fabulously cheesy plate of veggie lasagna or maybe a small piece of chicken and vegetables. And looking at this chart, I might make the choice, instead of going for the veggie lasagna, which I would have thought of would be good because it doesn't have meat in it, maybe the small piece of chicken with vegetables would be a better way to go. So the data is really helpful when we're trying to think about what we want to do, how we want to eat to help the planet. So this has two, it has a vertical line you can see going up the side here, right here, and that is where we say our pounds of carbon emissions are. And it has a horizontal line where our plant bars are, where we identify, or sorry, our food bars, and we identify the amount of carbon emissions per food. And along the vertical axis, each square is equal to 0.25 pounds of carbon. So when you get up to 4 squares, that equals 1 pound of carbon. And you can go over and see how that works. You start at the vertical line here. This is 0.25, and I go over, and I made my bar not quite all the way up there because it's 0.16 pounds for plants. All right, we are going to get into more detail of exactly how you make this chart. But before I do that, I just want to comment that this chart, this data is based on average people eating average types of food from the average refrigerator, average grocery store. If you, let's say you were going to have eggs, the pounds of carbon emissions for an egg would be significantly less if that egg came from chickens that you have in your backyard, because there's carbon emissions associated with transportation and packaging and retail, everything that goes into raising chickens on a farm and then transporting them to be packaged and then transporting them to the grocery store versus just walking down into your backyard. So these numbers would be different if the foods were local and sustainable. All right, so let's take a look at exactly how we're going to make this chart. All right, to give you instructions on how to make this chart, we're going to use my handy dandy dry erase board. And what I did was I made a cheat sheet, a unit calculation cheat sheet that will allow you to transfer a unit to pounds of carbon dioxide into a unit for the bar chart. So what this looks like is 1 unit of, or 1 square, as you can see right there, is equal to 0.25 pounds of carbon emissions per serving. So if you have 4 squares, 0.25, 0.25, 0.25, that equals, of a pound, that equals 1 pound of carbon emissions. Kind of think about it like quarters. 4 quarters equals $1. Okay? And know that 1 unit on your bar chart doesn't have to be a square. It just needs to be 1 unit can equal anything that is consistent in size. It could be 1 square, it could be 1 Post-it note, it could be 1 marshmallow, it could be 1 Lego brick. And you'll see some examples of that when we get into my 3D chart. So what I did was I did the conversion of pounds of CO2 to how many units. So plants, 0.16, and I did this by rounding to the nearest 0.25. So plants are, we'll just do rice, is 0.16 CO2, and I rounded up to 0.25, and that's 1 unit. So on my bar chart, I just went up 1 square. Milk, 0.75, I rounded, sorry, milk is 0.72. I rounded up to 0.75. That equals 3 squares on this graph bar chart, or 3 units on a different bar chart. 3 units of anything you want. Eggs, 0.89, I rounded up to 1 pound. That would be 4 units. Remember, 4 0.25s equals 1. Poultry, 1.26, I rounded up to rounded down to 1.25, so that's 5. And we go on down. Pork is 7 units. Cheese, rounded to 2.5, so that's 10 units. Beef, I rounded down to 6.5, which is 26 squares. Big difference between plants and beef. All right, so let's actually do this together. So we have our, in this, I'm using a marker so it's darker, but you want to probably use a black color pencil, because these are going to be done in color pencil. So what I want to do is I start 1, 2, 3, 4 squares up from the bottom, 1, 2, 3, 4 squares over from the side in this corner of my chart. All right, and I know I want to mark off each pound. So I mark off, I know a pound is 4 squares, 1, 2, 3, 4. Put a little mark there. 1, 2, 3, 4, mark, and measure all the way up to 7 pounds. And I do that because I know I don't have any foods that are over 7 pounds. 6.61 is the most carbon emission I have. So then I draw a line over, down. And then I want to mark my pounds. So I put 1 pound, 2 pounds, 3 pounds, 4 pounds, 5, and yours is going to be so much neater than this, 6 pounds, 7 pounds. Okay. Now to go over, hopefully you can see that okay. To go over, I'm up 4, and then I'm going to do 2, I give a space of 2 squares between each food bar. And the food bar is going to be 3 squares. So I go 1, 2 squares for space, 3 for my bar chart, for my food bar. 1, 2 of space, 3 for my bar, 2 space. And that's the base, as you can see, of my bars. So that, oh, oops, I'm going to draw the line all the way across. And then I'm going to do my food bars. So I know my first one is the lowest, which is plants. So I look up here and I say plants. Plants are 1.6 pounds of carbon emissions per serving. So that's 1 unit. So I know it's 1.6. So I'm not going to go quite all the way up. I'm going to go part way up, like that. And if it helps, you can do this. 0.25, 0.5, 0.75. All right, so my next one is milk, and that I've rounded up to 0.75, so 3 squares. So I go 1, 2, 3 squares over 3. And I actually want to label this plants. And I want to label this milk, and you will do it much neater than I am. And then you also want to put your pounds of carbon emissions on the chart as well. So I know this is 0.16, and I know this is 0.72. All right, so you just keep going. Please don't look at my messy writing. And do all your plant bars all the way across. And I'm going to bring up the bar chart so you can review what that looks like. So here I went all the way across, labeling plant, milk, eggs, and also putting the label on top of the bar of how many pounds of carbon emissions per food type, per serving. Now what I did here was I had a little bit of fun, and I filled in the bars with colors or features that represent that type of food. So you see here I have little plants, and I did white from milk, and I made the egg look like an Easter egg, and the chicken bar have a beak, and the pork have a squiggly tail, the cheese has some holes, and the beef looks like a cow. You can color these in any way you want. You can have rainbow colors, like the colors of the rainbow as you go up. You could have little patterns inside each one. They could even all be the same color. But where you really want to get creative is with your 3D charts, and that is what I will show you next.
This is my Post-it note food carbon emissions bar chart. Now this isn't truly 3D. It's 2D because Post-its are flat. Anyways, you can see that each Post-it is equal to 1 unit, and 4 of these units is equal to 1 pound of carbon emissions. So let's zoom in. Take a look. So what I have on this chart is each food bar is labeled. You can see plant, milk, eggs, poultry, pork, cheese, and all the way up here is beef. So not only did I label what the food is, for each one I labeled what the carbon emissions are. Then I put a title that is food carbon emissions associated per serving. And notice that even though you are getting information, this is still beautifully done. I did it in rainbow colors, so it would be very pleasing to the eye. All right, here is my Lego brick food carbon emission bar charts. And I got the idea from this when I found out about the Lego company getting in the energy business. Anyways, each Lego brick is again worth 0.25 pounds of carbon emissions. So 4 bricks equals 1 pound. And you can see each food bar has a label with the name of the food and a label above that with the pounds of carbon emissions associated with a serving of food. Then you can see I have my titles: food carbon emissions, pounds of CO2 associated per serving. But let's also talk about the artistic values of this bar chart. For the color palette, Legos are primary colors, so I used a background of yellow, which is a primary color. I used red color pencils to write because that blended in with the red bar, and that is also a primary color. So again, you can give information in an aesthetically pleasing and artistic way. This is my cardboard tube 3D carbon emission bar chart using, yes, toilet paper rolls and paper towel rolls. So my unit of measure for this bar chart was inches. 1/4 of an inch equals 1/4 of a pound of carbon emission. So 4 quarters equals an inch. So you can see for beef, here you have my ruler, beef is 6.61 pounds of carbon emissions, and it is 6.61 inches tall. And I did the same with each of my other tubes. Now, artistically speaking, what was important to me is this all came together with kind of natural textures because the cardboard is kind of a natural brown and washed out color. So I chose to use watercolors, which tend to wash out a little bit and look nice with the color of the inside of the cardboard tubes. I chose a cardboard box flap, which is the same color as the inside of the tubes. And then I used a bamboo cutting board as my background because that blended into kind of the earthy, natural, washed out feeling of the colors. I also chose to use color pencil because I need my labels, of course, and here are my labels. And color pencil isn't as bright as, say, Sharpie. So I have a label for each of the tubes in a coordinating rainbow color.
I also put the pounds of carbon emissions on each tube, which is another requirement for each bar chart, in black, so you can see it clearly. And then I have my title in construction paper, purple construction paper, because that's one of the colors on my palette. And I went ahead and wrote the rest of the title down here. So it is so important to think about all the little details when you're creating something that you want to be visually beautiful and appealing. Here is my quarter food carbon emissions bar chart. And on this chart, each quarter is equal to 1/4 of a pound of carbon emissions, or 0.25 carbon emissions. So 4 stacked quarters equals 1 pound of carbon emissions. And you can see I have my labels for each type of food. I have the name of the food, and I have the pounds of carbon emissions on the piles of quarters. I have my title there. And for this composition, I chose to incorporate a green and white color palette. And I was looking around for something green because I just had the dollar bills as my base and the white title, and I thought it looked kind of boring, and I thought, okay, how about some food? So on the plant end, I put a plant item, an avocado, and on the beef dairy end, I put Parmesan cheese, and you'll notice how the colors coordinate with the composition, and it works beautifully. So as you can see, I went a little bit crazy making some cool bar charts. It was really fun. I can't wait to see what you come up with for your bar charts. Remember, a unit of measure can be anything that's consistent in size. So you have a house full of things that could be really cool. So now you're armed with data on what would have the most impact, and that is thinking about what you can eat and changing what you eat every day, 3 times a day, starting today. And one thing that I have found really helpful is I went ahead and put my bar chart, I taped it onto my refrigerator. So it's there, because sometimes I can't remember, are eggs better than milk or pork? It's hard to remember, and just having it on your refrigerator will give you a reminder. And it also can help your family or friends or anybody who's in your house looking at your refrigerator think about that. Okay, have some fun. Bye.